Welcome everyone. I'm going to be talking about Zarr. This is a storage format for storing chunk compressed and dimensional arrays. My name is Sanket Verma and I take care of community and OSS at Zarr. I've been working there as a community manager for almost a year. I also have been involved with PyData since last 6 years. So I chair PyData Delhi, which is like my regional chapter, and I've also chaired the previous two PyData global conferences. This year, I'm not chairing the conference. This year, I just only took care of the program committee. And in the previous and before working to Zarr, I worked with forensics, startups, and organizations in data science roles. And when I'm not working, I like to play violin. And on the right hand side of your screen, you can see there's a pixelated version of my in my photo. This basically represents I like to do pixel art. And if you like this talk, you can go and follow me on Twitter. I post about a lot of cool things over there. So yeah, jumping into the topic today. So what I'm gonna show you, like what is Zarr, how Zarr works, and this is gonna be some like visualization using some pretty neat diagrams and stuff. And then I'm gonna jump into some code snippets. After that, like why and when to use Zarr. I mean, there are so many data science lab. There's so many data formats to use, and why specifically use Zarr, and then what is specification, and then implementations, and what community looks like. By the way, I also have the stream open on my other monitor. So if you have any questions, you can just post it over the YouTube chat. I'm having a look over there. So yeah, inception of Zarr. So how did basically Zarr started? So Zarr was created by Alistair Miles, and he used to work. He works with genome sequencing data of mosquitoes, which contains malaria viruses, and it started back in 2015. And he needed basically a data format to handle large data sets. When I say large, I mean in gigabytes and terabytes and petabytes. And that's where the Zarr basically originated, and it has a rapidly growing user base and and it's industry ready. Like we see, I mean, we always track the downloads in our PyPy and stats, and the numbers have been always increasing. And currently we have 21 core devs, which is for the Zarr Python implementation. And it is currently fiscally sponsored by NumFOCUS and also funded by CZI, which is Chan Zuckerberg Initiative, which is the non-profit arm of Facebook under their EOSS. EOSS stands for Essential Open Source Software. There are some links in the bottom of your screen, which is for Twitter, GitHub, and the website. So before I jump into the technical details and how Zarr basically works, so this is what I mean. I just wanted to show like how beautiful Zarr is. On the screen that you see, there are two types of data from different domains. On the left hand side, you can see oceanography data, and on the right side, you see microscopy data. So I mean, these data are basically stored in Zarr format, and you can just do a simple command and simple one line code, and you can get this data into your notebooks or in your browser. So yeah, I mean that's the beauty of Zarr. Let's, I mean, yeah, not spoiler alert. So yeah, so before we go into Zarr, like let's just have a look at what array or tensor is. So a container of item is basically known as tensor. When you want to contain items or data into a structured manner, you basically use arrays and tensor over there. So you can see there's a representation of like one-dimensional, two-dimensional, and multi-dimensional arrays on the screen. And we use different bits for the data, like 8 bits, 16 bits, 32 bits, and 64 bits. And these are different sizes of data that we use to represent our storage. The number of dimensions and items in container are described by shape. So basically, what your shape of data looks like is basically how the dimensions would look like. So if you have like a 1D data, in just a single row, it looks like 1D. If you have like columns and rows, then it looks like 2D data. And if you have column, rows, and then another axis, which is like 3D data, like in n-dimensional arrays, and it'll look like it will look like 3D data. Yeah. So yeah, I mean, what is Zarr? So Zarr is an open source specification format for storing chunk compressed and n-dimensional arrays. And I just want to break every term in this sentence. So so what does mean by specification? Specification is basically and a technical document which lays out rules of how the array should be stored, how it should be chunked, basically divided, how it should be compressed, and how it should be grouped into a store. And so Zarr is based on a technical document, and on the base of this technical document, we have implementations in different languages. So there are fantastic developers all around the globe who have basically used this technical documentation and created the libraries in Python, Java, Julia, JavaScript, C++, and I think the uh, R is also catching up. And so Alistair basically created the open source specification and the Zarr Python library. And since it's beautiful use case, other developers have also pitched in and they started making their own implementations. So yeah, let's dive into like how Zar works basically. So imagine this is your data that you want to store, and you can, I mean, let's just say this the size of this data is probably, I don't know, maybe 100 MBs or 200 MBs or few GBs. It's easy to store on your laptop, and you have, because you have disk space and you have memory. But what if the data is like too big to fit in the memory? It's impossible. Let's just say you have 1 TB of data. You don't, I mean, I haven't seen any laptop or any machine having 1 TB of memory. I mean, you could have disk space for like terabytes, but yeah, but not too big to fit in your memory. So what basically Zarr does, it divide your arrays into chunks, and you can see all this beautiful representation is basically divided into equal chunks, and compress those individual chunks using compressors. So there's a library known as NumFOCUS, which is also supported by Zarr, and which is also under the Zarr developers GitHub organization, which supports a range of compressors. So the default compressor that we use for compression is BLASK. Like if you don't mention like what compressor are you going to use to compress your data, the BLASK will be picked up. But if you specify what compressor you want to use, you can just do that using a string compressor. And when you compress those chunks, and that your data is basically divided into equal chunks and compressed, and you can retrieve the chunks only when needed. So let's just say you have a data worth of, I don't know, maybe a few hundred GBs, and you want to work with the only initial, like the first 100 chunks for the data, or the first 20 chunks of the data. So you can retrieve only those chunks, work with the data, read it, write some data to it, and then store it back into the storage. So that's the beauty of Zarr. Like you can basically store as large of as data as large as your disk size, and you can select the data you want to work on, which is sufficient for your memory, and then work on it, write some data on it, and then store it back. Yeah, so but how does the what does the organization, or what does the hierarchy looks like? So Zarr multiple arrays, like if you have multiple arrays, which is basically chunks, can be organized in hierarchies of groups. So the the violet blobs that you see, there are basically chunk data, which is in binary format, and the green blocks that you see, these are basically metadata, and which is in JSON format. So we have used the JSON format for storing metadata because it's easily like it's widely used and easily readable across different libraries and different systems. And yeah, this basically represent like how the chunking and the compression works basically. So every chunk is assigned a key, a unique key, and it is being compressed using the compression. And we basically use set item in Python. So basically we use mutable mapping to basically assign the chunk a key and its value. So value is essentially the compressed data which is in binary blob, and each blob is given a unique key and they are referenced by that key. So you take that contiguous chunks, like because these chunks are like contiguous, and pass it through any optional filters and a compressor, and that gives you a sequence of byte, and that sequence of byte gets stored as a mapping from the respective key. So conceptually, all of the Zarr store is just a key value store, and where key are strings and and values are sequence of bytes. So any system which can expose the key value system type interface can use Zarr store. So that's like really easy because there are a lot of stores in Zarr, like which are already built into Zarr, which uses this key value store mutable mapping. And in Python implementation, we use mutable mapping interface to set and retrieve Zarr data, which is like set item to set the keys and data, and get item to get retrieve the data using using the key and its respective values. So cool. So yeah, let's jump to some code. I have prepared a notebook. I hope my screen is visible.
Yeah, it's clear enough.
Okay, cool. So yeah,
Wait, I
so
think you
basic.
might increase the font size a bit.
Okay, sure.
For me to see it clearly. Oh, there you go. Good, cool.
Yeah, cool. So basically, Zarr Python API borrows many concepts from NumPy. So I just wanted to dive a little bit of basics of NumPy and how does it look like. So what we are gonna do here is create a NumPy array with the shape of 10 by 20 and using the float data type. So you can see the array is created, and we want to see like how basically the what the size of the array and what how does memory the array uses. It's 1600 bytes, and we want to basically getting a piece of data with slicing, so we're going to use the last two positions to get the value, and it's 00 because we haven't filled anything to it. And then we're going to use create a new array, which is b, and assign uh, the the a array to the previous one which you have created. And you can see the when we try to see the b, which is the first sorry, the first array, and the first position and the last position, you can see that it's being filled. So that's like pretty basics of NumPy, like how the NumPy array works and how the slicing works and how the assignment in the NumPy array works. So yeah, let's move on to our fundamentals and like yeah, what Zarr looks like how to basically create arrays and work with Zarr. So Zarr has three important properties, which is the shape, the data type, and the attributes. Uh, so what I'm gonna do here is I'm using the Zarr create function, and I'm gonna use the shape of the array of by thousand by thousand, like thousand columns and thousand rows, and I'm gonna divide the whole chunk into by 10 blocks, and I'm gonna use the float data type here, and this is the name of the like store like. This is stored into like I'm gonna show into the explorer like how does it looks like. So this is the test.zar which is gonna store. So let's go and run this command, and we can see that our code array is created with thousand by thousand shape of thousand by thousand, and its um, data type is float. So now we have this function zar.info, which basically shows the info of the array where we have just created. So you can see the shape is like thousand by thousand chunk. The order is C, uh, and the compressor is BLOS, which I initially mentioned that if you don't pick, I haven't picked any compressor yet. So you can see the compressor, the default compressor that have been picked here is BLOS, and the number of bytes it shows and number of bytes stored. And so the important thing that we have to see here is that the chunks initialized are zero. That I mean, the reason that initialized chunks are zero right now is because we haven't written anything to Zarr. And as soon as we start writing to your Zarr, the chunks will get initialized as you start writing. So let's just say if you write data to only your first 100 chunks, only those 100 chunks would be initialized. So we're going to see that in the next steps. So we're going to use fill value because I mean that's the uh, we're gonna use fill value to just initialize with like 00, like all the zero datas. So no data has been written to Zarr yet, but if it try to access the data, we'll just get the fill value. So because we used fill value, which is like a default zero, and this has been set zero. So you can see the initial chunk, which is the first chunk, which is 0 and 0. So now what I'm going to try to do is I'm going to write one into the first 500 chunks of the data. So when we do this, the data gets immediately written. So let's do this. Yeah. And if I'm gonna try to see this, it's gonna say 0 0 because right now there hasn't been written into the last chunk, like the last chunk, which is like 0 by 0. So and if I do like 0 by 0, you can see it's going to be 1. And if I go by Z info, you can see only the initial 500 chunks, sorry, 5,000 chunks are initialized. So you're basically, and I'm not sure if I can, is my screen visible if I shift to another?
Yeah, we're viewing another desktop right now. It's full
Um,
files.
okay, cool, cool. So you can see this is the test.zar which just has been created, and if I open it, you can see. I mean, I can go at the bottom of this. Uh, so yeah, it's gonna be only 5,000 chunks which are initialized because I've written only to the first 500 chunks. And if I go back to my notebook and if I go here and I'm gonna type to this, sorry, yeah, and I'm gonna do, yeah, let's do this. And if I'm gonna do Z info, so you can see all of the chunks are initialized. So your data was basically stored in the disk, but it was not, but it was it gets only initialized when you start writing to it. And if I go back here and you can see like, yeah, I mean, all the chunks are initialized and they have something written it. I mean, the data in it is binary, but yeah, you can see that chunks have been initialized. So yeah, I mean, so the beautiful thing here is like the data gets like you can read and write data according to your need. That's not like you have to load a big monolithic file and you have to work on that. So that's the beauty of using Zarr. And yeah, I mean, a little bit on the attributes. Okay, cool. So we can attach arbitrary metadata to our array via attributes, which basically is a very flexible thing and which is very beautiful thing if you're working with different applications, because your metadata contains the information about data, and you can manipulate the metadata according to your need. So I'm just gonna do like a unit meter per second and standard name wind speed. So you can see the z attributes, which was this metadata you can see over here is being changed by me, is being changed by just using a simple command. And if I want to see like what's happening under the hood, like how your data is actually stored, and so there's a Zarr store function which lets you look under the hood, and the ability to look under Zarr store and understand what is there is a very neat design. So I'm gonna do this, and yeah, so you can see there is like z array and z attributes, which is at the top, which contains the metadata information, and then comes your data. And you can also just use the simple JSON and try to see like what does your z array looks like, and it has all the information like what your chunks, the compressor information, the data type, your fill value, filters, your order, how you want to access your data, and what your shape and what your Zarr format is. So what does Zarr format 2 means is like Zarr specification version 2. And if I open Z attribute, which I just changed, and you can see its standard name is wind speed and unit is like meter per second. And there's one more thing. How much time? Yeah, okay, so we have time. Yeah, so we there's a group, like there's a very another neat feature in Zarr, which is like creating Zarr groups, and which is basically, I mean, in simple words, is the hierarchical organization of different arrays in Zarr. So I just created a group in Zarr, which is like looks something like this. And if I want to see, so there are like two folders, like bar, foo, and bar. And in bar we have different like bar, the folder baz, and then QX, and under QX we have two data sets, two Zarr data sets which have float data type and int data type. And under X and under Y we have similar data types with having float and int data type. And if you want to see this, so this is just a small visual interactive representation of what your group looks like. So if I can expand this and I can see, what's lying under my data set. So you can store multiple datas into different hierarchies using Zarr group. And I mean, that's really neat if you want to have like a tree structure of data and you want to experiment with different stuff, and you want to copy one data from one folder and go above in hierarchy and store data into that that folder. And yeah, and the last thing is like we can. So this is like a very neat thing. The string that you see here is the link for Zarr data, which is online, and I can just use simple Zarr.open to open this Zarr function. So to open the Zarr data, and I can print the values of the unique values of the Zarr data using this simple function. So this basically shows that Zarr is also compatible with cloud systems like Azure, Amazon, AWS, and Google Cloud System. There's a lot of documentation over in the Zarr official documentation which you can refer to. Cool. So I think I should get back to my slides. I do have a few slides to complete. Yeah. So I think I just showed you like what does the initialization, reading, and writing of Zarr looks like, and how you can organize arrays into hierarchies, and what the Zarr store looks like, and how can you manipulate the metadata of Zarr. And if you want to learn more, you can go to the official documentation, which is over here. So yeah, I mean, reasons like why you want to use Zarr. So arrays can be read and written concurrently from multiple threads and processes. So this is very interesting thing, and you can write to different chunks in multiple threads and processes. It's easy to extend and append, and it chunks arrays along any dimension. You can chunk arrays along any dimension, and it's due to the NumCodex library. It has extensive support for compression, and it's easy to plug in compressor just by changing the string value. It support local and cloud storage system, which is basically essentially any key value stored, and simple and based on open specification, which allows it to be hackable. And just to focus on the multiple concurrent writing of threads, if each so let's just say I think there's a very generic problem of write locks. So if each writer is writing to a different region of an array and all writes are basically aligned within the chunk boundaries, then locking is not required. And but if writer are not aligned with chunk boundaries, then locking could happen. So this is like one of the I would say uh, thing that needs to be considered when writing arrays writing to Zarr arrays concurrently. Yeah, and yeah, like when to use R. So just as I said before, like when you have absurdly large data sets and you don't have enough memory to work with that, and when you want to share big data sets across multiple points, having key value store really helps this. So if you want to like share your multiple data across like multiple points, you can use that key value store to basically extract only those things which are necessary and then share them. And if you're working in the cloud and you want to read and do concurrent writes, you can arrays and also be cool among your friends. So yeah, and one yeah. So I also have like this visualization, sorry, illustration to show like how Zarr is different from other file formats. So this was basically made by Henning Falk. We have other illustrations by him in our repository, in our GitHub repository. So on the left hand side, you can see there's a format known as TIFF, which is like 120 GBs of data, and it's like a big monolithic file which has binary data spread across its file. And if you want to share that data, that you need to basically pick up that whole monolithic file of 120 GB and just share it on the point. But instead, like we have Zarr, where everything is like chunked and compressed, and you can access data across through any dimension and through any you can just, if you have the key, you can access the data. So it's not like that you have to go through the whole data to just get the last byte of the information. In Zarr, you can use the key to just access the last byte, and you can just do that. And I just showed you the how does the Zarr store looks like in a file explorer. Yeah. So okay, so yeah, so it has a technical space. I mean, I think I talked briefly about what Zarr specification looks like. So it has a technical specification. Zarr specification provides a technical protocol for format for storing Zarr arrays. Currently, version 2 is in effect, and it basically tells us how hierarchies are organized, how arrays are chunked and grouped, and how metadata should look like. And we are actually moving really fast with V3, which is the next version of the specification, and there are some big changes over there, and you can track the progress over here at step 1. I would share the slides after the talk, so you can have access to all of the links. Yeah. So another thing. So another beautiful another feature which makes Zarr beautiful is the interoperability. Sorry. So Zarr read and write to Zarr stores using you can read and write to Zarr store using Dask, Xarray, and data. So and other libraries which are under PyData ecosystem. So you can see I have just attached this screenshot for how does the how does Xarray how you can use Zarr using Xarray. So you can open your Zarr store using Xarray with the simple function xarray.openZarr, and you can write using dataset like xarray to dot dataset to Zarr. So basically, Xarray, Dask, and data have backends of Zarr built in them, and you can basically use Zarr without using Zarr. And that's an ambiguous statement, but yeah, that's how it is, and that's how much the community loves Zarr, and they have been using it. And we have also examples for Dask, like how you can use Zarr from Dask, and this is like load and writing, like loading the Zarr array and storing to Zarr array. And just as mentioned, we have implementations in different languages. So Python being the most used one, and then we have C++, then Java, C, Julia, JavaScript, and several more. And yeah, the specification is open source and free. So if you want to start implementing Zarr, yeah, just hit me up, and we are more than happy to help you. And yeah, Zarr community. So Zarr community is essentially the users, the developers, the maintainers, the contributors, and everyone who uses Zarr in any way. And I mean, there's no formal process to join us. Just drop over to our Gitter and say hi. We hold bi-weekly community calls where you can basically join us, and if you have any questions, you can just drop us and let us know. If you do anything exciting with Zarr, feel free to tag us on Twitter and let us know on the Getter on GitHub. We are more than happy to uh, uh, echo it. And yeah, and we also have this ZEP, which is the new governance process for Zarr, and how does new feature will implement in Zarr spec. I'm not gonna dive more into V3 because I'm running out of time. But yeah, I think that's it for the talk. And these are some examples for data sets, which is like you can see on the left hand side, which is the 54 terabytes data of sea surface temperature, and on the left hand side you can see 1 petabyte data of climate model data. So these are like really big data sets, and you can see they all use Zarr to store the data sets. And you are welcome at our community meetings. This is the link for our community calls. We just had a community call yesterday. We're gonna have this ZEP meeting today, which is about ZEPs. And also, we are doing a sprint tomorrow. So you are welcome to join. And maybe this would be your first open source contribution. And we have a lot of good issues to work with you. So yeah, see you all. I hope it was informative. If you have any questions, feel free to drop them into the chat or Discord. I'm going to be on the Discord. And yeah, thank you.